So what I gotta say is, dropping in today, I'm really impressed with everybody's participation. So like that's awesome. This is tough, and it's good to see. It's really good to see. So hopefully we do some more fun stuff with electricity, and it's a subject that I spent a lot of time in my life learning about and sharing with other people. So I'm really happy that I get to share it with you today. Um, and My goal, since we have maybe 3 days in a little bit, is really just to get you comfortable with the fundamental concepts and using some of the test equipment. And then, since you have the kits for so much longer, if you're comfortable with those concepts, you can then go. You can. There's so many experiments that we can do with these kits. Um, so what I want to start with today is just the basic concept of voltage and current, and if we have enough time, getting to how we connect circuits in different ways, and what that does to voltage and current as we measure it. We'll do a little bit of measurement. I think we can fit that in today as well, and then we can wrap that up tomorrow, and then maybe start building stuff even tomorrow, which is, I think, no, I think that was always the plan, but maybe we can do even more, which will be cool. How comfortable? Yeah, Discord is totally awesome, Zoe. I totally agree. Um, it's been really good for me to hold. Sorry, a total aside. It's been really good for me to hold my students together in a community, um, which I love doing. So,
Great. Now I have to learn another software.
well, you don't have to learn another software. But I have a great group of students that stayed together over the summer, and we watched the SpaceX launch party together. And some of the alumni are now helping my seniors do their senior projects, which is awesome. It's kind of nice to see everybody gather together and virtually when we can't be in the same room. So it's been awesome. Um, I have it in the background too. So um, anyhow, yeah, I'll show you that trick too.
Perfect. Okay, cool.
But you can come in the server. You're cool enough.
Okay, cool.
Okay, so how many of you are comfortable? I'm trying to get a gauge of where to begin talking to you. Have you heard of the concept potential energy before? Okay.
But I'm assuming not mechanical potential.
Well, there's mechanical potential energy, but really we want to relate that to electrical potential energy as well. Multiple times. Okay. You don't want it one more time? Okay. So let's see here. Let me pull you down here. I'm going to put myself in the corner. Like all of 8th grade. Wow. Okay. It's, I have to think back. I grew up in Connecticut too. Um, I have to think back. So I think our educations are probably similar, but I don't know that I learned about potential energy in 8th grade. I'm not sure. I can't remember. That was a while ago. I won't tell you how long.
Oh, come on, last year.
Yeah. Longer than you.
Not really.
Yeah. Okay. Okay, that's cool. I love that you're doing basic physics, I think, a little earlier than I did them. That's great. Okay, so potential energy is, we talk about potential energy. You probably talked about potential energy in the gravitational field, right? We can take, let's see here, draw you a picture, and let's get colors. Okay, so we talk about potential energy being related to the height of something off the ground, right? So, and you're really moving in the gravitational field, and I think that's something that's a little more intuitive because we exist in the gravitational field. So we have this idea that if I pick something up and then I drop it, we know which way it's going to flow. So I think it's far more intuitive than potential energy in an electric circuit because we can't see it. We don't exist in the electric circuit. Hopefully not. If you do, then something went very wrong. And that release of energy is something that we can like touch and feel and see and experience. Um, we drop the ball and it falls to the ground. Or if it's a spring, we can talk about potential energy in springs, and we compress the spring. Or a bow and arrow, we pull the string back on the bow and arrow, and when we release it, it creates movement. Well, we're going to do the same thing with electric potential energy. Okay, so I'll just write a couple notes over here. Potential energy, we're really talking about mechanical uh, and electric. Okay, so gravitational, I think, is the easiest one. Let's see, gravitational. We can talk about potential energy with a spring. These are both mechanical, of course. But then the one that is near and dear to my heart is, of course, electrical. Did you talk? Okay, so in all of your basic physics stuff, did you talk about potential energy in electric circuits? No. Okay, cool. Good. I get to teach you something. That makes me happy. um, rolling balls. Okay, so yeah, and so I drew steps, but if you had a ramp, you could talk about how much energy uh, is converted from potential to kinetic um, when you release the ball at the top of the ramp, right? So let's see here. Okay, right. We dropped that ball. If we want to, um, if we want to use that energy to do something, with your gliders, you were releasing them maybe with a little thrust, but gravity might have allowed you to get some momentum, and then the lift could take over. So with mechanical potential energy, I think it's a little more obvious what we're doing. We're expending that energy to lift something, to move it, maybe to transform it, things of that sort. With electric energy, okay, we're going to use electrical energy, potential energy, to do. We can kind of group everything we do with electricity. We can group it into two categories. Uh, use electrical. We want to do. We want to do work. Think about motors spinning, any kind of manufacturing, kind of to ease the human burden is the kind of fancy way to talk about it. Um, but we want to do work. We can create electric light, things of that sort. Those are all forms of energy that we think of. But the more modern one, and when I say more modern, I mean like 1800s and later, but it's certainly taken over um, life more recently. The fact that I can talk to you and we can share information is become a really big part of using electricity. So we either want to do work with it or we want to convey information. So my hope is that we kind of work through how to do work, the basic fundamentals, and then at the very end, if we have time, we'll talk about some digital stuff because that's more and more that's becoming what we do with electricity, which is kind of cool. Um, I'm pretty happy we have it right now. Okay, so voltage, and voltage is really a form of potential energy. So I want to take the concepts that you learned with the rolling balls and the idea that this ball on top of these stairs has some potential energy. I want to take that and relate it to voltage because I think in that way it can become more intuitive. If you think about moving objects around a circuit as adding energy and then using that energy to do something, it becomes less of this mystical thing that I find a lot of people get hung up on it. I have some friends that are high school physics teachers, and they don't even like to talk about electricity, which is a shame because um, I think you have the basic concepts. So let's just put them together. Okay, so voltage is, let's see here, voltage is our potential energy. Okay, to start with. It's just a different form. We're moving around an electric field instead of the gravitational field. And we still want to think about how we change energy. How does the ball lose energy as it rolls down the ramp? How does the one I drew up here change energy as it steps up? Okay, so we call our reference point, we often call it ground. So we can have some fun with it and put some grass on the ground. We often call it ground, but really what we're talking about is our reference point. So where do we have no energy? So let's see here. So we'll go with green. We'll stick with green. Ground is our reference point. Okay, everything's measured from that point in the circuit. Or if I was measuring the potential energy of this ball, I would measure it from the physical ground. Okay, so reference point in the circuit. Okay, 0, and I cross my zeros. I usually get picked on for that in class, but my undergraduate degree was in computer engineering, and we write a lot of ones and zeros, and you got to make sure that you make your zeros clear there. 0 potential energy, okay. And at some point, I'm going to stop saying potential energy, and I'm going to start saying voltage, because in my mind, they are synonymous. Okay, so does anybody remember, did you do some basic calculations with potential energy? Like measuring how high something was and doing the calculation? Yeah, what was the other thing that you had to measure besides the height? Yeah, okay, so yeah, how heavy it is, how high it is, and the gravitational field all play into it, right? So if we were going to measure, let's see, grab white. If we were going to measure our height off the ground here, okay, we call that h. This, whatever the object is, has some ball m, and then we have some gravitational constant, okay? So you may have seen it put together and say the potential energy is the product of all three of those. Okay, we can do the same kind of thing with an electric circuit. We want to measure the difference in energy, okay? And that's what voltage is a difference in energy. So if I was going to measure the height from the ground up to my little ball up there, do I even have my tape measure? I don't have a tape measure. Do I have a ruler? I got a ruler. Okay. We might take a ruler, or I would have started with a tape measure, and we have to connect that ruler to both sides of the distance, right? We have to put the ruler down here, and that's our reference, and that's going to be 0, right? So I might start with the side of my ruler that's 0 over here, and then I want to measure up to the height, and that other side is going to be the side that has the measurement along with it. Okay, so when we're measuring voltage, we're measuring potential energy. We have to measure across some distance of the electric field. Okay, so a lot of people will say voltage goes through things, and I always correct them as quickly as possible. We measure voltage across some distance or between 2 points in the electric field. And then I half jokingly, I don't know where you're all going to go to college, but I half jokingly say that if I ever catch you saying you measure voltage through something, then you should follow up with "Go Huskies," because I don't want people to think you went to Central. So we've got to teach you right. Okay, so we measure voltage across things, not through. So let's see. So we're going to measure it with a multimeter. Let me see if I can grab a picture. I have the multimeter that came with the kits, which is great. What I loved about that was you got a real test tool. So maybe you want to pull that out of the kit now. And I have a close-up picture that I'm going to try to put on the screen in a moment here. But go ahead and grab this out of your kit. And it's a tool that I use. I have far too many of them. So like I have my own personal one sitting here. This one's kind of a cheapy one that I keep in my toolbox. But I have some higher end ones that all do the same thing. Oh, I have a fancy one. I have a bench one. They come in bigger models. If you're working on a test bench, you might have a bigger one. I'll try to grab that for tomorrow. I think I have it in the back of my basement here. Anyhow, this is the tool that we're going to use to measure that change in potential energy. And just like with the tape measure, it has two sides. Okay, so go ahead and grab the red probe. I got alligator clips. I'm all tangled up here. Go ahead and grab the probes. Okay, and the probes look like this. Okay, you got a red and a black. And we're going to use this to measure the change in potential energy at the different points in the circuit, just like you use the tape measure. So you need 2 points, and that's why you have 2 probes. Okay, so the zero, you got to know which side is which. So just like on the ruler, you always start with the side of the ruler that you think of as 0. With the multimeter, you're going to start with the black probe, and that's going to be what you think of as 0. So if there's a ground in the circuit, you're going to connect the probe to the point in the circuit that's ground, or what you're using as a reference. And then the other side of the measurement is the red probe. That's the point where you're saying, okay, how much energy does that point have that compared to the other one? Okay, so just like with the ruler, how far away from 0 am I when I take my measurement somewhere over here? Okay, we're saying how much energy do I have at the red probe when I compare it to the black probe? Okay, let me grab that picture if I can, so that we can point to it. There's a little glare, but I think it'll help if we get a close-up that looks like that. Okay, so I already have them plugged in. Oh, it's backwards. I got to get used to that. I'm in the other corner. Okay. I already have my 2 probes plugged in, and most multimeters have multiple places you can plug things in. So the ground, the reference point, has a couple symbols on it that that make sense, or maybe not make. They make sense to me. I guess I've just seen them a little. But you want to put the black probe in the one all the way on the bottom. It has 2 symbols. It has the symbol for the ground. So in a schematic, we would usually have a symbol that looks like that. Okay, and that's a ground symbol. And the other thing that it's labeled is COM, which is short for common. Okay, and the use of the word common to describe ground, you're going to find more when you're doing electrical work, maybe in your house. You may have two connections, and one would be called the common, and the other would be called the hot, if you go talk to an electrician, which is what my mother still thinks I am, despite studying engineering for so long. Anyhow, so you'll see both of those labels, and it's really meant to be correct for both the person using this multimeter for electrical work in a house, which sometimes I do measure things from my house wiring with it, and also the symbol is more correct if you're looking at a schematic. So you'll see those both labeled on the multimeter, but that's our 0 point. We're going to use that connection to the electric circuit as our reference. Okay, let me grab my notes again. Okay, the other side is the red probe, and there's a couple places you can put the red probe. There's 2 holes that you can pick for the red probe. And if we look down here, we can see they have 2 different labels. This multimeter is unusual. When I started playing with the kit and I wanted to play with the test equipment that you would have, it's a little unusual, and I'll tell you why in a moment. So the middle hole is labeled V, which is what we think of as voltage. You can see a capital omega, which is what the symbol for resistance. Okay, let's see V. I'll try to draw an omega, and then it's labeled lowercase m and a capital A, so that's a milliamp, which is unusual to have all three of those together. On a more typical multimeter, you're going to measure voltage and resistance, okay, and all of the current is going to be on in a different, you connect it to a different hole, usually in a different hole. So I thought it was, I think it's really cool that you have like a real multimeter to play with and do this stuff. But this one's a little unusual, so I don't want you to get complacent and think that this is typical. I'll show you on mine in a moment. Usually measure electrical current in a different, with a different port. Now this one has a different port, which I also found interesting. So it has the port up here, this one here, that's labeled 10 ADC. So if you want to measure higher currents, you can measure up here. But if you want to measure lower currents, you can measure down here. Okay, so this will measure both of the values that we're really interested in. So let's see, let me see if I can find this one. I don't have a picture of this, but hopefully I'll make myself big again just for a moment. Oh, and we got stars again. Okay, so if you can see that one, you can see the common is labeled in the middle. And then, oh, this one doesn't even measure. Wait a second. Oh, this one's cheap. It's my red one. I'll go find a red one for later. Like I said, I have a few of them. This one doesn't even measure current. And I think, and so this one's unusual too, because it measures just voltage and resistance. Okay, so pay attention to those symbols. You're usually only going to have one ground, and then you'll have holes that are labeled with the units for the type of value you're measuring. So for now, let's get to the little, make me little again. For now, put the red probe, since we're talking about voltage, we want to put it in the hole that's labeled V. Okay. The great thing about the green screen is you can't see how messy it is around me. So someday, come visit my office. I would love it if you'd all come visit the office, and you'll see. So let's see here. We need something that can create this change in potential energy. And there's a few ways to do it. There's some are more common than others. How do we create this change? In potential energy or voltage? Okay, is that behind my head now? Okay, I'll roll out of the way there. How do we create the change in potential energy? Let's see here. Let's go up. Okay, so the ways that we have and that you have in your kit. Where'd it go? Where'd it go? I was playing with it earlier. Like I said, a little messy. Okay, I'll find it. It's somewhere. What are some ways you can think of? Let's play with that, because I'm sure there's some that I'm even forgetting. You got 2 in your kit. I'll give you that hint. And then I can already think of a third. Nothing? Battery, yep. That's probably the most common. And that's what I'm trying to find right now. Okay, so we can create that change in potential energy with a battery. What's another way we can do it? Uh-oh. Input and outlet. Yeah. Okay. So that one's actually really complicated. But you're right. It can come out of the outlet. But if you want to change, if you want to make that change, you have to think about everything that goes into what feeds your house with electricity. And that's really going to come from a power station and some kind of generator. Okay. If you have any hurricanes, friction. Well, that is a form of energy. Um, you can create static electricity from it. But static electricity is static electric. A physicist would argue with me, but static electricity, we can't do the same kind of work that we do when we make charge move. Moving charge is useful. We can do work with it. We can convey information with it. Static electricity, I can make. I was going to say I can make my hair stand up, but sadly I can't anymore. And we can do. Whoops. Let's see if I can grab this picture. You can see if I can find that slideshow quick. You can do fun things with it. There we go. Ready? You can make we can make his hair stand up, or we can do horrible things to cats. Okay, but yeah, I do need a wig. um, so there we go. And I even quoted myself in my own slides. How horrible is that? Electric charge is more useful and interesting when it moves. So the other way that we can do it, which is kind of a neat way that is becoming more common, is we can use our solar cell. Okay, so we can take chemical energy from the battery and create this difference, right? We can take mechanical energy and turn it into electrical. Chemical. If I spell something wrong, don't tell me. I don't want to know. Okay, so chemical energy, we can take mechanical energy. And then what's really cool about the photocell, and now you have a little photocell that we can play with now, is we can take light energy. Okay, photovoltaic. Okay, so we can take solar energy and we can generate electricity. So it's pretty neat. With the generator, think about a gas engine turning the generator, or in a nuclear plant, they're going to create a lot of heat and generate steam and have that steam spin a turbine. So that's all mechanical in that respect. Okay, so I want you to find your voltage, your little battery pack. I did take a picture of it. What I can't figure out is I haven't left this chair since I took this picture, so I know it's around here somewhere. Grab that picture, just so you know what I'm talking about. Okay, so this is the first one that we can play with pretty easily. Okay. So in your kit, you ended up with a battery pack that looks like this, and it's going to have some chemical energy, and I want you to go thermal. Yeah, that's thermal energy. That's an interesting one. There are some ways to take thermal energy and turn it into electrical as well.
You need a different type of device to read it, though. Most likely, thermocouple will be able to do that, but
it's small. It's very inefficient.
Yeah.
What's the other? Can't think of the word. The thermoelectric coolers can do it as well.
Yeah. There are different transducers too that might be able to.
Yeah. Yep.
Yeah. It's easier to go from electrical to heat than heat to electrical.
Yeah. So with a thermocouple moving that way, we're still using electricity, but what we're doing there is conveying information. We're not necessarily using and generating a lot of energy that we can use to heat your home or lights or anything like that. But what we're doing in that instance is conveying information. We're taking a measurement of how much energy is present in some environment, and we're turning that into an electrical signal, and then we can read that electrical signal. So it's still useful, but it's not useful to do a massive amount of work. Just a little bit of work, and it's the work that's necessary to convey some form of information. But that was that's a great comment that we can think about thermal as well. Okay, I really want my batteries. I'm really upset that I can't find them. Okay, so with this battery, we can take some basic measurements. So turn the dial on the multimeter. So let's scroll back up here for a moment, and can zoom in on this one. But we can measure. It's called a multimeter because it can measure all sorts of things. It can measure voltage and current and resistance. And this one can do some fancy stuff. It can check diode, which we do have some diodes that we'll play with. And it can also check transistors, which is pretty fancy stuff. Okay, so we want to start out by measuring what's called it's called direct current voltage, which is a horrible mishmash of words. Really, all that means is that it's constant. It's not varying with time. So we want to measure a DC voltage, and we can set the range. So this multimeter is not auto ranging. Fancier ones are, but that's okay. So you set the dial to whatever value is higher than the voltage you think you're going to be reading. So with that battery pack, I think you really want to set it to 20 volts. Okay, because you're not measuring 20 volts, you're measuring 0 to 20 volts. So it's setting the high end of the range. Let's see. So go ahead and set it to 20 volts. Hopefully they will turn on. The batteries in mine were in good shape. And then we want to make some connections. And I think the easiest way to make connections to your multimeter are using alligator clips. So let me get a close-up of that as much as I can. We call these alligator clips, and I think it's because they are vaguely similar to an alligator. I think, yeah, you can kind of see that. I think it's a little out of focus, but the kit came with a bunch of these, which is nice for making some quick connections that you're not going to use that much. Okay, so I would start out by, let's do red to red on everything. Okay, so grab your red alligator clip and connect it to the red probe. And then on the other side with the alligator clip, connect it to the red side of the battery pack, which I don't have right now. Okay, but connect that here. Okay, and then do the same thing with the black. All right, so let's see. So red, is this behind my head? Here, I'm going to disappear for a second so that you can see what I'm writing. Oh, that's backwards now, isn't it? Red alligator clip. Okay, to that, connect to the red probe. Okay, and that's all going to connect down to the multimeter. So we abbreviate that as DMM a lot of times because it's a digital multimeter, and that stems from the olden days when I was learning that we only had analog multimeters, so it had a needle on a dial that we'd see. Okay, do the same thing, right? Get a black alligator clip. Okay, and then once you have that measurement, yeah, this is from the solar kit. Is that the question? Are these components in the solar kit? Hopefully. Right, connected up to the red probe.
Yeah, that should come from the solar kit.
Yeah.
From the little kit.
I think that's, yeah, that's where I found mine.
Yeah, that one. The Solar Lab.
Oh, I found it. Fell on the ground. Fell on the ground.
Are the batteries for the solar one or for the other one?
These batteries came in the solar kit, and
Already.
they're rechargeable.
Okay.
So these are, different batteries have different chemistry. So these batteries, if we look, well, maybe you can see it on the picture. Of course not. None of the batteries are rotated correctly here.
Okay, so but the question is, do they have to put them in? Okay, cool. You can see it now. Okay,
Yep.
good.
Okay. I'm trying to keep up with the chat too.
No, it's okay.
So thank you. I really prefer when people interrupt me. It's fantastic. So I'm
Which people interrupt me?
I know, right? Certainly with a small group like this, it's always fun. Okay, so these batteries are nickel metal hydride. Yours are green? Cool, we got a variety then. Okay, so go ahead and minty green, nice. I love it. Okay, go ahead and connect that up and measure the voltage across this battery pack and drop it in the chat for me. Just so that we know we're measuring voltage. $376, okay. How much do I
Should
get?
have kept that kit for myself.
Hey, I didn't get a glider kit. I'm a little jealous.
Now I'm jealous. Okay, Casper had 377 and 379.
Okay, that's good. I think your batteries are a little more charged than mine. So, which is good to hear. Okay. Okay, so we're measuring voltage, and what you're doing is measuring the two different points in the circuit. One of the points in the circuit, okay, it's a really simple circuit, it's just a battery, is the black side of the battery pack, and the other side is the red. So that's the same idea of just stretching a tape measure across those 2 points. Okay, so that's the easiest way, and I think the easiest demonstration that we can get with that. Let's do 323. We're going to 330, is that right?
Yes, 330.
330? Okay, let's do one more thing today, okay? Let's grab the solar cell. Okay, and it looks like this. And there's actually multiple individual cells in this, and we'll talk about that tomorrow. But what I'd like you to do today, as I alter mine, or let me see if I have a picture for you. I'm going to ask you to go outside. I'm in a basement, and my window's covered with my green screen. So I don't know what the weather's like. Is it raining out for you guys?
No, it's beautiful. They were just doing gliders.
Okay, good. I think it was supposed to rain later, but shiny, nice. Okay, so that's going to be important. I want you to take and measure the output of one of the solar cells to start with. So let me grab another picture of the solar cell. I have some wires connected to it. You don't need wires connected to it. Okay. So, but for now, let's connect up to one of the cells. So I want you to take the red probe. So go outside. If the alligators help, go ahead and try to clip them to these posts, and then connect the other sides to the red and the black probe. Connect one here. Let's see, to this side, and it says positive, so I'm going to use the red there. Okay, and then connect the other one. Let me grab black right here. Okay, so go take a quick measurement, come back, look at what's going on. Are there clouds? Is it bright out? And try to face the panel at the sun. So make it, if there was a line from the sun to the panel, make the panel perpendicular to it. And then move it around and see what you observe. Okay, so let's take a few minutes to do that. I think it should be pretty quick. And you can measure the voltage coming out of from the sun, the solar energy, and how it's being converted to an electrical difference in potential. Stuck it out the window. That's not bad. That works too, Casper. Okay. Okay, so it varies, and it's going to vary with the intensity of the sun and the angle of the panel to the sun, and it's also going to vary a little bit with temperature, and also just how good a panel you have. So this is good for kind of playing and experimentation. Okay, what I want you to do is make some connections, and I have most of them in this picture. I need to move my whole. Did I just slide over to the other side? I think I did. Yep. Okay, so in this picture, you have multiple solar cells, just like we have multiple batteries with our battery pack. And we're going to make a connection, and we're going to put them in a formation called series. And I'll get a little more formal about what series is tomorrow, but I think that you can take a little bit of time now to make some basic connections and then see what's going to happen with this. So with the solar cell, I took this little yellow jumper wire, and there should be 2 of them in your kit. And the picture I have, let me unscrew something here and see if it can show up for you. Come on. Okay. It has this little ring on it. I'll put it over my forehead so there's some contrast. Okay. And I want you to unscrew the little thumb wheel that comes with it. So you can see I have the full connection here. Okay. And I made one connection between them. So if we were talking about this formally, I'd say I created a node by connecting the 2. So we talk about this point in the circuit as a node. So we connect those 2 with a wire, and they're now connected in what we call series. And I'll get a little more formal about that tomorrow. But I want you to do that twice. Okay, so from just like I have it here, and then I want you to connect this wire. Let me grab yellow, grab this one, and put it on that thumb wheel. Okay, so that it's another hop between those. All right, and then let's do a handful of measurements. I'm going to screw mine together, and I can show you. There's a little washer. There's probably a right place to put the washer, but that's what I fondly call a mechanical problem. It's really just meant to keep the thumb wheel from coming off. It's a little lock washer. You're going to be fine no matter where the washer goes. Okay, so I hooked mine up just like that. Oh, my green screen is playing funny with it here, but okay. So what I did was I took the 3 cells. Okay, I have one solar cell here, one solar cell here, and one here, and I connected them in series. And then I want you to repeat the measurements. Okay, you can look at this one down here. Let me. It might be good to draw a picture here. Okay, so measure from one side to the other. So use this as your reference. Okay, so and when I say reference, that's where we're considering it to be 0 potential energy. And that's where we're going to connect the black probe. Okay, so connect the black probe there. And then take 3 measurements. I want you to take 3 measurements. And bring these with you for class or whatever this is tomorrow. Bring it with you tomorrow. Take 3 measurements. One each at the positive terminals. One each at the plus terminals.
David, they're asking if you need to connect it to the positive sides together. Don't you have to connect positive and negative?
So you're connecting positive and negative actually to put it in series. So okay, so there's 2 jumpers. Oops, that's my stylus for writing. do this. Okay, so your black probe is going to go over here, and then from plus to minus, you're going to connect a jumper, and from plus to minus, you're going to connect another jumper. Okay? I got one okay. I think that's better. I'll take a better picture of this, and can you get them photos?
Yes. Well, I'm going to. So yeah.
Okay.
I'm going to share this video. So I'm going to post it on YouTube, and then I'm going to share the video with everybody. So if you have any questions or any additional things, you could email me or email Dr. Broderick, so that we could continue this tomorrow.
Yep. Yeah, each at the positive.
Okay.
Yeah, go ahead, Zoe. No problem.
I'm going to share it to the people that had to leave earlier today. So.
Okay.